Hello everyone, this is Paul Bertorelli reporting from the Continental Centurion diesel engine factory in St. Egidian, Germany, where they've given us unusual access to the factory. I'm standing in the middle of the engine assembly line here, and we're going to take a detailed look at how these engines are put together. But before we get to that, here's Ken Suda to give us a general overview of how the factory is organized.
We are a fully integrated design, manufacturing, and testing operation, all under one roof, which allows us great flexibility. Which supports our model, which I would characterize as flexible, be that small lot manufacturing prototype or full up series production of general aviation engines. We can run in this configuration 1,500 to 2,000 engines per year. So we are fully flexible from 1 to 2,000. Well, we're cellular, whether that's in manufacturing or assembly. Currently across our 7 stations in assembly, you've seen an interesting mix of high-tech work instruction, integrated software that guides the employee step-by-step with full traceability for our parts, and integrated quality checks. So quality is in fact built in before the work is allowed to be released to the next station. This is truly the next generation. This is state-of-the-art technology, whether it's manufacturing or integrated design. But Continental Motors in Mobile is well into their transition from batch to one-piece flow manufacturing. There's been some great work done there in the last 7 to 10 years to bring them forward much closer to where we are here today.
Continental's St. Egidian factory is located in the former East Germany, right near the Czech border. It's the former Thielert Aircraft Engine Company, which Continental bought in July of 2013. The factory is in the heart of the automotive manufacturing region in this part of Germany. That means it has a skilled workforce and state-of-the-art machining equipment feeding a modern, flexible assembly area. In addition to the engine factory, Continental has a test and support facility at nearby Altenburg, a former East German MiG base. In fact, the original Cold War-era bunkers and revetments are still visible. Altenburg serves as both a test facility and an assembly and shipping point for completed engine kits. Continental's 4-cylinder diesels, once called the Centurion line, are now known as the CD100 series. They trace their genesis to automotive diesel engines, so it's no surprise that the company uses many automotive spec components. However, Continental will soon add a new V6 to its diesel line, so it's expected to evolve toward a more vertical manufacturing process. It certainly has the capacity to do this. The factory is well equipped with computer numerical control machine centers capable of producing most of the engine parts required. These machines are quickly reconfigurable to accommodate short runs. The plant specializes in crankshaft machining, both for Continental engines and for other manufacturers, including high-performance automotive. Primary foundry work and forging is done out of house, and components such as pistons and valves and the crankcase castings are purchased from vendors. That's pretty much standard in the industry. But with its substantial machining capacity, Continental does its own critical machining and all of the assembling. This machine, for example, is completing cylinder heads in a computer-controlled sequence. Having evolved from automotive cores, Continental diesels incorporate manufacturing methods used in car engines. For example, connecting rods are forged as a single piece, then they're laser scribed and cracked apart at the big end via hydraulic ram. The resulting surface texture yields a stronger joint and a more accurate fit around the crank journals. The engine assembly area in St. Egidian is surprisingly small. In this view, you're looking down the entire length of the assembly line. The engines are rolled along the line from station to station on trolleys. Like most modern manufacturing plants, Continental uses a Japanese-developed Kanban or lean just-in-time inventory system. Subassemblies are built up in cells off the main line and stored in bins or shelves until the assemblers need them. Engine buildup starts with the crankcase and crankshaft and proceeds through 7 stations, which add the pistons, the cylinder head, the induction and fuel systems, and other components. One assembler takes the engine from raw crankcase all the way to completion, and that process takes a bit over half a day. In any kind of manufacturing, quality control accrues from high volume. But Continental doesn't have that for its diesel, so it relies on an electronically monitored production system in which each assembly step, right down to the torques or individual bolts, is recorded for future traceability. The system is interactive enough to lock these assembly tools in the rack until the computer knows they're needed and knows that the previous assembly step has been done. For those operations that can't be electronically verified, such as installing the cam chain, the assemblers use the so-called 4 eyes method. That's another way of saying they check each other's work. Here's Continental's Marcus Steinberg with more on Continental's engine quality control.
Then we have the anti-traceability, and it's linked with the assembly protocol of an engine. So each torque or whatever is part of the protocol, and even after 10 years we can take and pick a protocol and see who assembled an engine with which parts and where the torques appropriate or not. That's essential for the engine and the quality. And that's a major step ahead in comparison to the old style assembly we had previously. This was a single spot where one mechanic had all parts and the paper manual and a manual torque wrench, and was assembling the engine from more or less scratch. The main cross-check is done by the assembly stations itself. So whenever there is a torque or torquing angle required, the mechanic has to wait until he gets a green light. So we have the red-green system, and many of the assembly steps are semi-automatic and automatically cross-checked during this process.
Once the engine is fully assembled with all of its electrics and plumbing installed, it goes into the test cell where it's broken in and tested. It gets a final inspection, and then it's prepared for shipment to the customer. You can find a detailed report on how Continental builds diesel engines in the August 2014 issue of Aviation Consumer. For Aviation Consumer and AvWeb, I'm Paul Bertorelli reporting.